In these next few videos, we are going to be looking at parallel and perpendicular lines. We come across these a lot in geometry, so I need to remind you about your algebra according to parallel and perpendicular lines. So first, lines. We have slope, so reminder about some slopes. So the slope of a non-vertical line is the ratio of the vertical change, we usually call that rise, and the horizontal change, which we usually call run. Okay, so that's rise over run. Or the formula over here is y2 minus y1 over x2 minus x1. So just a reminder, I know you guys have learned that already. Also, visually, negative slope falls from left to right, just like line J. And then a positive slope rises from left to right, just like line K does. And then an undefined slope is vertical, just like N is. Okay, so that would be undefined slope. And then a slope of 0 is a horizontal line, like this one right here. Okay, so nice reminders for you. And parallel lines, hopefully this is a review, but if not, take notes on it. Parallel lines have the same slope. And since vertical lines have an undefined slope, we also know that any two vertical lines are parallel. And I think you guys know that. Perpendicular, I don't know if you guys learned that in Algebra 1, so if you didn't, again, please take notes. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So that's why this is saying the slope of the first line times the slope of the second line equals -1. Another way of saying that is we say that the slopes are opposite reciprocals, because that's what has to happen in order for the product to equal -1. So if I have a slope of 1/5, the other slope would have to be -5/1. So the reciprocal part, remember that's the fraction flipping around, and opposite means that they're opposite signs. Okay? Horizontal lines are always vertical, are always perpendicular to vertical lines. Okay, so just know that again, since we don't have slopes to for a vertical line, we cannot use that product property. So that's what just a theorem or a postulate that we know for sure. I probably won't ever write perpendicular again because it's long. So just so you know, a standard symbol for perpendicular is like an upside down T. Okay, just like the symbol for parallel looks like a slanted 11. Okay, so just symbols you need to know. All right, so if we find the slope of each of these, we can determine which ones are parallel. So reminder of us finding the slope from a graph, you can count rise over run, so that's 1, 2, 3, 4, 5, and then over 1, so the slope of K1 is 5. Okay, you can also just use coordinates. So here on K2, I've got the coordinates 2, 2, and 1, -4. So you can subtract y2 minus y1. So that is -6. This is -1. So that's -6 over -1. So K2 has a slope of +6. And on K3, I'm just going to count again. So 1, 2, 3, 4, 5, and then over 1. So this one has a slope of 5/1. So obviously K1 and K3 are parallel, but K2 is not parallel. In this example, I want us to draw a line that passes through those 2 points, and then we're going to graph the perpendicular line that passes through that other given point. So at 1, -2, and 5, 6, there's our line. So if I want to do a perpendicular line that passes through the point 2, 5, here's 2, 5. Okay, we can do a few things. We can count this. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. So this is 8 over 4, which is a slope of 2. So our slope of h is equal to 2. So if I want a perpendicular slope, then that's going to be the opposite reciprocal, negative 1/2. So that tells me when I start at this point, 2, 5, I would go down 1 and to the right 2. Down 1 and to the right 2. And I know that that line is guaranteed to be perpendicular. Keep in mind that perpendicular means that they are at right angles. Okay, that's very helpful in geometry. We've already been using that in right triangles with Pythagorean theorem and whatnot. Okay, so now if we do this without a graph, we have a line N passing through those points and line M passing through those points. They want to know if those two lines are perpendicular. So all we're going to do is the slope of N, which would be, remember, this is x1, y1, x2, y2, if you're more of a formula type of person. So that's 4 minus 6 over 8 minus 1, so that's negative 2 over 7. And then the slope of M, okay, again, x1, y1, x2, y2, so that's 12 minus 5 over 2 minus 0, so that's 7 over 2. So you can see that these are opposite reciprocals, or if we did the product of them, they would multiply to give us negative 1. Sorry, this one's positive. So this is by definition. I think it's probably easier and quicker to just identify that these are opposite reciprocals, so you know that those are perpendicular. In the next video, we'll talk about writing equations of these lines and review those skills from Algebra 1.